लेक्चर अटेंड कर ला.
Can you hear me?
Yes, sir.
Okay.
Yes.
Okay, let's go ahead. So I think we have solved this exercise yesterday. So today I will switch over to next part, that is De Mor's theorem. But in fact, other than this exercise, I have solved few more exercise. Okay, but I don't want to solve again because it will be repetition for 50% of you. I will share this in Google Classroom. I have solved some exercises like see if I write the exercise which I have solved, if x equal to if x equal to cos theta plus I sin theta and y equal to cos phi plus I sin phi, then show that x minus y upon x plus y equal to I tan theta minus phi by 2. Okay. And maybe you might have done it in your lower classes. I don't know. But anyway, I have solved this exercise in the regular class. I will share with you all in your respective Google Classrooms. So if we have sin psi is equal to I tan theta, then show that cos theta plus I sin theta equal to tan pi by 4 plus theta by 2. Sorry, psi by 2. It is not theta, we have psi here. It is psi by 2. So this is another exercise which we have solved in the last lecture. In fact, I had given one homework also, that also I will share with you in the Google Classroom. So with this exercise, let me switch over to the next part of the exercise, that is De Mor's theorem. Okay. This is over. De Mor's theorem. This is yes. So what is the statement of this? If you look at this syllabus, there is a statement you should remember. For any real number n, okay, for any real number n as one of the values, then cos theta plus I sin theta, remember this is I sin theta whole to the power of n is equal to cos n theta plus I sin n theta. This you already know it. Okay. So whenever we have cos theta plus I sin theta, a complex number in this particular form, the power of this, okay, the power of this, which is n, gets multiplied with the angle theta. So it is cos n theta plus I sin theta, where your n can be, what? It can be positive integer, it can be negative integer, or it is a fraction of the type p by q. It can be a fraction of the form p by q. So keeping this in mind, positive, negative, and fraction, how we have certain simplifications. Okay. Say, for example, you can say some observations. Okay. Suppose if I write z is equal to cos theta plus I sin theta, then what is your 1 upon z? So this is going to be cos theta plus I sin, sorry, it is cos theta minus I sin theta. It is going to be cos theta minus I sin theta. So as you know that 1 upon z, okay, note that 1 upon z I can write as z to the power of minus 1. Okay, but I know what is z. Z is cos theta plus I sin theta. Cos theta plus I sin theta, and its power is minus 1. Power is minus 1. So I can apply De Mor's theorem here. Whenever we have a number of the form cos theta plus I sin theta, this is very important. First number should be cosine, second number should be sine. Okay, so imaginary part should have sine theta. So I can multiply this n to each of this angle theta. So therefore I can write this as cos of minus theta plus I sine of minus theta. Okay, but you already know that cos of minus theta is plus cos theta, and sine of minus theta is minus sine theta. So it becomes minus I sine theta. Okay, it becomes minus I sine theta. So we have 1 upon z equal to cos theta minus I sine theta. Instead of 1 upon z, we can take 1 upon z raised to n also. We can extend this to or in general, one upon z raised to n is equal to cos n theta minus I sine n theta in general. Okay, now suppose is one more observation. Instead of suppose cos theta plus I sine theta, if we have the number say sine theta plus I cos theta, so then can you express this in this particular form? Yes. So if we have sine theta plus say I cos theta, say let us it has a power also n, then I can write this as cos of, first of all, Sine theta, I can write a cos of 90 minus theta plus I sine 90 minus theta and raised to the power of n. Okay. But once again, whenever we have a number cos theta plus I sine theta type, we can always use De Mor's theorem. Okay. You can always use, this is I. You can always use De Mor's theorem. That is cos n theta plus I sine theta. Okay. You can always use. So therefore, I can write this one as cos of n 90 minus theta plus I sine 90, sorry, n in 90 minus theta. Okay, cos n times 90 minus theta plus I sine n times, this n is there, okay, n 90 minus theta. This is how we make adjustment when we come across sine theta plus I cos theta while solving the exercise. Okay, with this in mind, let me solve one simple exercise. Okay. Show that 1 plus I root 3 whole to the power of n plus 1 minus I root 3 whole to the power of n is equal to 2 to the power of n plus 1 cos n pi by 3. Okay. It is very simple. Okay. First of all, I will simplify what is 1 plus I root 3. Okay. So let me write 1 plus I root 3 in the polar form as r cos theta plus I sine theta. Okay. So if you want, you can call this as equation number 1. So if you equate real and imaginary parts, you find, okay, then 1 is equal to r cos theta and root 3 is equal to r sine theta. Square and add. Squaring and adding. 1 plus 3 is equal to r square, implies r square equal to 4, that is r equal to 2. R is never a negative, so therefore we take only the positive side. Okay, so the radius is 2, so I can write here r equal to 2. Next, what is theta? Okay, in order to find theta, one thing is very much clear, that this 1 plus I root 3, it lies in the first quadrant. Okay, it has the component 1 root 3. So since it lies in the first quadrant, so theta is always positive. Okay, so therefore, and if you look at the second one, it lies in the fourth quadrant, that is 1 minus root 3. Okay, so therefore, whatever theta you get, you take minus theta of that, so that will be the amplitude of the other complex number. So let me find what is theta first of all. Okay. If you divide these two, also, if you write r sine theta by r cos theta is equal to root 3 by 1. So r get cancelled, implies tan theta is equal to root 3. So what is theta equal to? So theta is tan inverse of root 3, which is nothing but pi by 3. 60 degree, correct. So therefore, I substitute the value of r and theta in equation 1. So therefore, your equation 1 becomes 1 plus I root 3, 1 plus I root 3, R is 2, and this is cos pi by 3 plus I sin pi by 3. Cos pi by 3 plus I sin pi by 3. But what we want here is the power of 1 plus I root 3 to be raised to n. Now, okay. Secondly, you can also write 1 minus I root 3. This will not change. This will have only negative sign. So, similarly, you need not calculate in the examination. You can simply state that 1 minus I root 3 falls in the fourth quadrant. Therefore, on similar lines, we can write 1 minus I root 3 is equal to 2 cos pi by 3 minus I sin pi by 3. Okay. So now I'm looking for 1 plus I root 3 power n. So and now 1 plus I root 3 to the power of n. So it is 1 plus I root 3 is 2 cos pi by 3 plus I sin pi by 3. Write down cos pi by 3 plus I sin pi by 3. Okay. So if you take the power n, so this is 2 raised to n cos of n pi by 3 plus I sin n pi by 3. I have multiplied this n to this angle pi by using De Mor's theorem. Okay, so I have used here De Mor's theorem. Okay, so this is 2 to the power of n into cos of n pi by 3 plus I sin pi by 3. Remember, you should always put a bracket over here. Otherwise, 2 raised to n will be only a multiplying factor for cos n pi by 3. Okay, you should identify very clearly that this 2 raised to n is for both cosine and sine term. So 1 plus I root 3 is over. We call this as equation number 2. Okay, and similarly, one minus I root 3 whole to the power of n is equal to 2 raised to n into cos of n pi by 3 minus I sin n pi by 3. We call this as equation number 3. Okay, this you already know it by using once again De Mor's theorem. I have found whenever you get 1 plus I root 3 and to the power of n, clear solution, we can write straight away on similar lines 1 plus I root 3 also holds good. So now I have 1 plus I root 3 to the power of n and 1 minus I root 3 power to the power of n. Okay, then add. Okay, we need to add here. So therefore, adding equation number 2 and 3. Adding 2 and 3. So 1 plus I root 3, left hand side, 1 plus I root 3 to the power of n is 1 minus I root 3 to the power of n. So 2 raised to n, okay, it is cos n pi by 3 plus I sin n pi by 3 plus 2 raised to n cos n pi by 3 minus I sin n pi by 3. Okay, so if I take 2 raised to n common throughout, so I have here cos n pi by 3 plus I sin n pi by 3 plus cos n pi by 3 minus I sin n pi by 3. Okay. Plus I sin pi by 3 minus I sin pi by 3 get cancelled. So we have 2 raised to n. This is 2 times cos of n pi by 3. That is equal to the power of n plus 1 cos of n pi by 3. Okay, this is what we supposed to write. Okay, so 2 to the power of n plus 1, 2 to the power of n plus 1 cos n pi by 3. So in view of this, let me take up one more exercise. You can take one homework also if you want. Show that 3 plus 4i 4 to the power of 2 by 3 plus 3 minus 4i 4 to the power of 2 by 3 is equal to 2 times 5 to the power of 2 by 3 cosine of 2 by 3 tan inverse of 4 by 3. Okay, so solve this is very simple. Here you get 3 by y by x. Okay, y by x, tan inverse of y by x is 4 by 3. So we have here tan inverse 4 by 3.
Sir,
Yes.
can you explain the starting part of this sum? Previous sum.
What happens? Screen is not visible?
No, sir,
Someone
it's
is writing
visible.
screen. Visible or not?
No, sir, visible. It's visible.
Visible or not visible?
Visible.
Visible.
Okay, okay. You know, one of you has written that it is not visible. That's why I asked. Jagtap. Janmay Jagtap. Mechanical. Maybe we have some network issue. Just check it out. Okay. So now I will take up another exercise. If alpha and beta are the roots of the equation, x square minus 2x yes. Did I meet all of you?
I keep cracking.
Can you hear me? Can you hear me? Can you hear me? Okay, take it. Good. So if alpha beta are the roots of the equation, x square minus 2x equal to 0, show that alpha raised to n, beta raised to n equal to the power of n plus 1 cos n pi by 3. Okay, and also deduce that alpha raised to 6 plus beta raised to 6 equal to 128. So here we have got the equation. What is given to you here is x square minus 2x plus 4 equal to 0. Find the root. Minus b plus or minus b square minus 4 is c upon 2a. Okay. Minus b plus or minus b square minus b is plus or minus b square 4ac 16 upon 2a. If you simplify, 2 plus or minus 4 minus 16 is minus 12, 4 3s are. So it is I 2 root 3 upon 2. So this is nothing but 1 plus I root 3. It is 1 plus I root 3. So I don't think there is a need to continue further. Okay, this is your x. So it says that if alpha and beta are the roots of the equation, if alpha and beta are the roots of the equation, so let me call here the two roots. Let the two roots be alpha equal to 1 plus I root 3 and beta equal to 1 minus I root 3. So what they want is the summation. Sorry, take the power of alpha, take the power of beta, okay, that is to the power of n. Then alpha raised to n plus beta raised to n is nothing but 1 plus I root 3 whole to the power of n, 1 minus I root 3 whole to the power of n. Okay, this is exactly same as what we have done here. Okay, so the same example is written in another way, and I already know how to solve this further. First, by writing this in polar form, that is r into cos theta plus I sin theta into bracket, and then find r and theta, take the power. Okay, that is what we have done it here. Okay, first express in polar form, find r, find theta, okay, and take their powers. Okay, take the powers, add them, you get 2 raised to n cos n pi by 3. So therefore I can write here directly that is alpha raised to n plus beta raised to n is equal to directly. Okay, only the reason is we have done it. Okay, so I write here so already covered. Okay, so this is nothing but 2 raised to n plus 1 into cos of n pi by 3. So therefore here we have alpha raised to n plus beta raised to n, that is equal to 2 raised to n cos n pi by 3. Same example. Okay, but here one additional thing is being asked, that is alpha raised to 6, beta raised to 6. Okay, so put n equal to 6. So it is alpha raised to 6 plus beta raised to 6. So 2 raised to 6 plus 1 cos of 6 pi by 3. So 3 to the 6, cos 2 pi is 1. So what is 2 raised to 7? Two raised to 7 is 128. Two raised to 7 is equal to 128. So as an application, let me solve a few more exercise. Okay, if sine alpha, if sine alpha, sine beta, plus sine gamma equal to 0 and cos alpha cos beta plus cos gamma equal to 0, then show that alpha show that cos 2 alpha cos 2 beta, first one, cos 2 alpha cos 2 beta cos 2 gamma equal to 0. Also sin 2 alpha sin 2 beta sin 2 gamma also is equal to 0. Okay, it's also 0. So the second part is cos square alpha cos square beta cos square gamma equal to 3/2. Okay. Also sin square alpha sin square beta sin square gamma is 0. Okay. And then we may have what is cos of alpha plus beta, cos of beta plus gamma plus cos of gamma plus alpha is equal to 0, and also sin of alpha plus beta plus sin of beta plus gamma plus sin of gamma plus alpha, this is also equal to 0. And the last one is cos of 3 alpha plus cos of 3 beta cos of 3 gamma equal to 3 times cos of alpha plus beta plus gamma and sin of 3 alpha sin of 3 beta sin of 3 gamma is equal to 3 of sin alpha beta plus gamma. So we shall try to resolve all these 4 cases by using only these 2 equations, this one and this one. Okay, so let us start. So maybe you have to adopt some other ideas, identities studied in lower classes. Let us see. So here what is given to you here is cos alpha cos beta plus cos gamma equal to 0 and sin alpha sin beta sin gamma equal to 0. See how we are going to generate the relation out of these two. So here, what I do here is I combine these two equations in the form of complex number, that is cos of alpha cos of beta plus cos of gamma. So let me write here consider, so plus I times sine alpha sine beta plus sine gamma, okay, is equal to 0. 0 plus I 0 actually, okay, because both are zeros, so I can write this. As you already know that in a polar form of a complex number, always the real part contains cosine. So I have taken all the cosines as the real part, and sine terms, they are the imaginary parts. They are real number associated with this imaginary number. So therefore, I have taken all the sine functions along with I. So therefore, there is a reasoning, okay, behind writing this particular step. Now with this, I have a liberty to extend further using the De Mor's theorem. So I take cos alpha plus I sin alpha, that is cos alpha plus I sin alpha, one term, plus cos beta plus I sin beta, second one, okay, and lastly cos gamma plus I sin gamma equal to 0. Okay, so this is actually the complex number. If I assume, okay, with the notation, okay, if A is equal to cos alpha plus I sin alpha, B equal to cos beta plus I sin beta, and C is equal to cos gamma plus I sin gamma, okay, then you can write one A plus B plus C. A plus B plus C equal to 0. Okay, this is very, very important result. Okay, I think you can also give me the exponential representation of this. This is e raised to I alpha. You can also write this as e raised to I beta. Okay, this is also e raised to I gamma. I think I have already, I don't know whether, just a minute. See, here we have written exponential representation of a complex number. B plus I is equal to R e raised to I theta. Okay. See here, this is the exponential form. This is the polar form. And cos theta plus I sin theta is expressed as e raised to I theta. So this is your polar form. Okay. Sorry, the exponential form. So therefore, given any complex number z, you can always write it as R e raised to I theta. Okay. So that particular notation I want to use here. That is cos alpha plus I sin alpha is e raised to I alpha, and this has e raised to I beta, and this is e raised to I gamma. There is no R here, so therefore I skip that particular thing. Okay. Okay, this is the first equation. You remember this. Also, okay, cos, see, I have here added 2, right? Complex number. Can I take this subtraction? Yes. I can also subtract. That is also cos plus cos beta plus cos gamma minus I sin alpha plus sine beta plus sine gamma is also possible. So therefore, if you simplify, this is going to be cos alpha minus I sine alpha plus cos beta minus I sine beta plus cos gamma minus I sine gamma equal to 0. Okay. So therefore, this can be written as, see, cos alpha minus I sine alpha. If you remember, in the beginning itself, we have seen cos, instead of theta, if you take it as alpha, cos alpha minus I sine alpha is nothing but cos alpha plus I sine alpha to the power of minus 1. Okay, it is minus 1. So that particular idea I am going to use here. So this is nothing but cos alpha plus I sine alpha to the power of minus 1, cos beta plus I sine beta to the power of minus 1, cos gamma plus I sine gamma to the power of minus 1 equal to 0. But this notation I have taken as a to the power of minus 1, right? Cos alpha plus I sine alpha is a plus b to the power of minus 1 plus c to the power of minus 1 equal to 0. So it is 1 upon a plus 1 upon b plus 1 upon c equal to 0. Okay, and if you simplify a little further with ABC LCM, it is going to be AB plus BC plus CA equal to 0. Okay. So therefore, we have one more result, AB plus BC plus CA equal to 0. Okay, this is also one of the important results. So this will help you, okay, to derive one of the results. Maybe here I'll show you. It will help you to derive the result number 3. Okay, I can solve this particular result 3 here itself if you want. Okay, otherwise let me solve this in sequence. Now let us go back to one by one. That is, how do you find cos 2 alpha plus cos 2 beta plus cos 2 gamma equal to 0. For this, the first one, I use a plus b plus c the whole square is nothing but a square plus b square plus c square plus 2 times ab plus bc plus ca. AB plus BC plus CA. But I know that AB plus BC plus CA is 0, and I also know that A plus B plus C is 0 from 2 and 3. Okay. So this is A square plus B square plus C square, this is 0, okay, from equation 2 and 3. So therefore, we have A square plus B square plus C square equal to 0. What is A? A is cos alpha plus I sine alpha whole square, cos beta plus I sine beta the whole square. What is C? See here, I have already written here the value of A. Okay, and this is the value of B. This is the value of C. So already we know what is A, what is B, what is C, which